We're at Oregon State University. I'm with Dr. Chad Schmid, who is an assistant professor now.
Hi Micah, good to be with you.
We had a ATC double cut last autumn and we talked about this experiment that we're standing on now. I had a chance to visit. We can look at this thatch and we can talk about this very interesting Poa annua putting green management. Shall we have a look?
Yep, let's do it. Yeah, this is our long-term cultivation and top dressing trial. So we are just starting our 5th year of this trial, and we're looking at different tine types, either hollow or solid tine, and sand top dressing rate. And we're also looking at timing of the cultivation event, either in the spring or fall, or both spring and fall. So we've accumulated some pretty big differences between plots as far as organic matter goes in that time frame.
Yeah, we took a couple of cores here. Can you show me? These are from the 2 plots. So clearly, now that this is drying down, one of these is obviously from a plot that's getting some coring.
Yeah, so on my left here, we have our treatment that's probably our most intensive. So this is hollow tine, twice a year in spring and fall, and receives 100 pounds of top dressing sand every 2 weeks during the summer, starting about June 1st through mid-September. We have 2 rates, the 100 pounds per thousand on the top there, and the 50 pounds per thousand. And so this is applied bi-weekly through the summer. We usually get 6 to 7 top dressings in during the summer.
So I want to interject here and clarify about the rates. Are those annual rates of sand, or are those per application rates?
Per application, so 100 pounds per thousand, which is about 2 cubic feet per thousand, I think is the conversion. So it's 2 and 1 cubic foot. And then the core on my right here is our non-top dress and non-cored plot. So this has received no cultivation in the last 4 years, about 4.5 years. And you can see all the thatch that's accumulated on that surface there. And you can really feel it when you're walking over the plots. It's almost kind of a drop down where we haven't built up that sand top dressing and cultivation layer, and you can really feel the difference in firmness at the surface between these treatments. So really big differences that have accumulated. But visually, if we kind of look at the plots, not a huge difference in the color and quality this time of year. So everything's pretty happy and growing pretty well right now. So we'll start to see the plots start to separate in the middle of summer when we get into a little bit more heat and stress, and that's where our non-cored and our top dressing only treatments really start to suffer and look poor compared to everything else. But in mild conditions like we have this spring, everything looks very similar at this time point.
So in the conditions of this study and the way that this green is managed in this climate, the results so far of the 5-year study, of this long-term study, are that more sand and more coring gives better year-round results.
Correct, yeah. Anytime where we do any kind of cultivation, either hollow tine or solid tine combined with top dressing, we have better quality than when we're not coring and not top dressing, or top dressing alone. If we start looking at some of our infiltration data, the best treatment overall obviously is our hollow tine twice a year and the highest rate of sand top dressing. And those are really starting to separate now from our solid tine treatments, where we're seeing a subtle decrease in infiltration rate. So we're talking our hollow tines maybe 8 to 10 inches per hour, where our solid tine is maybe around the 4 or 5 inches per hour now for the infiltration rates on these plots. So we're starting to see a separation between those treatments after the 4th year.
I'm here with Emily Braithwaite, a graduate research assistant at Oregon State University.
Hi Micah, thanks for having me.
Yes, it's a pleasure to be here, and you're working with grass, but with something a little bit underground, right?
Yes, so I'm specifically interested in plant parasitic nematodes as part of my research.
All right. Can you tell me a bit more about that? So you're working with plant parasitic nematodes.
Yes, I am.
And what type of species and what type of damage do they cause?
Yeah, so this project kind of spiraled out of, we were seeing more reports of damage associated with nematodes in our region. So a general thinning of areas, a lot of things that mimic abiotic stress. So because they're underground, they're kind of hard to quantify. We had very limited information on populations in the Northwest. So we've started surveying a lot of locations, and what we're seeing is that populations of root knot nematode and spiral nematode seem to be much higher than we had initially thought. They're above available thresholds that we have, so warrants some more information and looking into when we see damage, which is typically at different times of the year than other locations. A lot of our injury is occurring in the fall through spring period compared to other locations that see a lot of damage in the summer months. So we're just kind of digging into early research onto what those populations are and how widely distributed they are.
Wow. And this is on, is it worse on sand-based greens? I've heard that nematodes are high populations sometimes in sand root zones.
Yeah, so putting greens make a great environment for nematodes because they are sand-based. You have larger pore sizes for those nematodes to move around from plant to cause damage. So we do see more damage on those sand-based root zones.
And you said it mimics abiotic damage, so it doesn't look like a disease, it just looks like traffic or something?
Yeah, so a general decline, you get thinning of the stand. A lot of it looks like nutrient deficiencies and wilt stress because feeding from those nematodes is inhibiting that process of nutrient uptake and water uptake. So it mimics a lot of those abiotic stresses we see.
And it happens more in the winter.
It does happen more in the winter, yes, in our region. And some of that might be because we're seeing slower growth from the grasses at that time. We have more ideal conditions for the nematodes with that constant moisture, but we are really seeing that most of our pressure from nematode damage is fall through spring here.
And if I had a suspected problem, if I suspected that this could be an issue, how could I check for it?
Yes, so soil sampling is going to be really beneficial to give you an idea of what populations you have. Sampling before you see damage is critical because that's when the nematodes are active. And part of what we're doing is surveying in Oregon, Washington, and California. So if you're managing cool season grasses in those regions, we are looking for participation. So you can contact OSU to get involved with some of the surveying efforts that we're doing. And we are hopefully expanding into British Columbia this year.
Okay, and is there a particular website that people can check, or should I put that in the video description?
If you put it in the video, then I can direct link to me the information.
Okay, I will do that.
Perfect.
Thank you so much.
Thank you.
You've done a frost study here also, and you've tested traffic damage on frosted turf. What was that all about, and what were the results?
Yeah, so this is some research that Alec Corvallis, myself, and a couple of graduate students worked on for the past couple years, and we are looking at the idea of putting traffic on frosted turf and what kind of damage we'd see. So we looked at two different kinds of traffic. We looked at cart traffic and roller traffic, and then we looked at three different species of grass. So we looked at annual bluegrass for our cart traffic and rolling. We looked at creeping bentgrass for our cart traffic and perennial ryegrass for our cart traffic. And we saw some interesting results. Basically, bottom line is, if the temperature is below freezing in the morning or 32 degrees Fahrenheit, we saw damage or injury from that traffic both in the morning and in the afternoon as well. So that was pretty surprising for us. Even though soil temperatures had gone above freezing in the afternoon, we were still seeing some damage from that. The most damage we saw was from cart traffic on creeping bentgrass, which was also somewhat surprising, but we did see some discoloration on all of the species of grass. We never saw any thinning to the point where we had death or any kind of open space on the putting greens, but we definitely saw some yellowing from the treatments. So pretty interesting trial.
Yeah, that's interesting. And when you did the pilot study a couple years ago and looked at foot traffic on putting green Poa annua, putting green height Poa annua, the foot traffic actually didn't cause any problem, did it?
Correct, yeah. We did not see any damage from foot traffic in frost, and I've kind of periodically walked over some frosted turf since then to see if I could recreate any damage, and we haven't seen any yet. We're probably not the most extreme environment. I would say we maybe had only 10 days below 32, and we never really dropped below like 25 degrees Fahrenheit. So we don't really have tremendously hard frost, but we do see a half a dozen to a dozen frost delays during the winter when we have play in Oregon. So something that our superintendents are really interested about.
And this, so you saw damage on this fairway. This is the bank grass that did see some damage.
Correct. Yeah.
But now it's May 10th.
Yeah.
Of course, it's all grown through that. It didn't kill the grass.
Yeah, you can't even see where the plots were or any of the traffic from earlier in the season. So we probably had frost into early March, maybe late February. That was our last frost event. And everything's kind of recovered since then. We don't see any kind of lingering damage from any of those treatments. So we've kind of gone around and looked at all the locations trying to find residual damage, and we haven't been able to see any out here today. So nothing lingering from those treatments.
Well, Chaz, it has been great to see the research here with you. Thank you so much for your time.
Thanks for coming to visit us. It's been great.
Thank you.
Yep.